Hello. In my last video, I talked about bad parameter sniffing, what it is, and especially what you can do about it. And I told you in that video that starting with SQL Server 2022 and then later in 2025, Microsoft has introduced two new features intended to help alleviate those problems without you having to do anything. And I promised that I would talk about them in separate videos. This is the first. Here I'm going to talk about parameter sensitive plan optimization, a feature that was introduced in SQL Server 2022. For that reason, try to address bad parameter sniffing issues. Let's watch to the end of the video before we conclude whether it is the answer to bad parameter sniffing. Spoiler, it isn't. So in that previous video, I mentioned the three common root causes for bad parameter sniffing. An equality predicate on a column that has a very skewed data distribution. An inequality predicate where the selectivity varies between executions. And procedures with optional parameters. Those are the three main reasons for bad parameter sniffing. PSPO addresses only one of them. So if you suffer from bad parameter sniffing due to inequality or optional parameters, this feature isn't going to do anything for you. Simply no. Only equality predicates on skewed columns are addressed in this feature. Now, let's talk about it in a bit more detail. Like I said, it was introduced in SQL Server 2022, and you also have to have the proper database compatibility level. And then there's also an alter database setting to disable this feature. By default, it's on. If you disable it, or if you are on SQL Server 2019 or before, or if you are not on the right compatibility level, then all of this video will not apply to you. This is only for people running SQL Server 2022 and up with all the settings such that PSPO can kick in. Now, what Microsoft did in SQL Server 2022 was they introduced the so-called multi-plan infrastructure. Traditionally, queries are always associated with exactly one execution plan. And I need to put a footnote here. If you run with different combinations of ANSI settings or other settings, then that is no longer true. Technically speaking, I should say every query is associated with one execution plan per collection of relevant settings. But let's, for ease of discussion in the rest of this video, assume that you always use the same collection of settings. Then every query is always executed with exactly one execution plan at a time. That execution plan may exist in the plan cache, in which case we can reuse it without a new compilation, or it may not be in the plan cache, in which case, if the query runs, we need to compile the query first and then store it in the plan cache. And once it's there, it will be reused. Over time, there may be recompilations that result in different execution plans, but at a given time, a query is always associated with one execution plan. In SQL Server 2022, that stops being true. The multi-plan infrastructure allows SQL Server to associate a single query with multiple execution plans at the same time. So the first layer in this multi-plan infrastructure is the so-called dispatcher plan. If an execution plan qualifies for the PSPO feature, and we'll get to the qualification rules later, but if a query qualifies, then that query is not associated with one single execution plan, but with one single dispatcher plan, which is also an execution plan, just a special type. So the query is still directly associated with that single dispatcher plan. And in that dispatcher plan, you do not find the execution plan operators. You find a collection of up to 3 dispatcher expressions. Those dispatcher expressions are then used by SQL Server for each and every execution to look at the current runtime values of the relevant parameters and determine whether this specific parameter value has a low, medium or high frequency in the histogram of that specific column. Do we expect that this parameter will hit only a few rows, a moderate number of rows, or an insanely high number of rows? Low, medium, high. This dispatcher plan is a really simple plan. It's still stored in the plan cache, because even creating a dispatcher plan takes some time, so why wouldn't we store it? Now, whenever a query runs, like I said, we find the dispatcher plan, we compute whether the relevant dispatcher expressions result in low, medium or high frequency, and that results in a so-called query variant. For each query variant, we then have a separate execution plan. And as it says on the screen, there's a maximum of 27, because you can have 3 dispatcher expressions. Each of those 3 can have low, medium or high frequency. 3 times to the power of 3 is 27 possible execution plans. And they all get stored in the plan cache too. Now, not every query gets 27 variants. Most queries will still not qualify for PSPO, so they will not have a dispatcher plan, will not have query variants, they will still have just a single execution plan. Those that do qualify for PSPO will not always use all 3 dispatcher expressions. There might be just 1, there might be 2. And then the query variant, the plans for the query variants are only created and stored if they are used. So if some query variants are for combinations that just never happen in your system, then there will never be an execution plan for that specific variant. So there will be more execution plans in your plan cache, but it will not be 27 times as much as it is now. Far from. It will be a bit higher in most cases. So this is the theoretical foundation. Let's look at this in action in the demo. And for this demo, I use SP execute SQL as the easiest way to demo parameter sniffing. I could have created a store procedure or anything, but that's not needed. This is simple enough. And I have a demo table with 4 values, A, B, C and D. The value A exists just once, the value B 100 times, the value C 99,999 times, and the value D 100,000 times. So without PSPO, this first SP execute SQL would sniff the value A, create an execution plan optimized for just 1 row, and then that execution plan would be stored in the plan cache and reused for the second execution, which runs for 100,000 rows. That is exactly the problem I talked about in my previous video. We want to fix that. And without changing code, just by using PSPO, SQL Server, Microsoft do that for me, with some limitations. So let's look at the first execution plan and see what we can see. The first thing I want to point out is that in the query text there is some text added. This is text SQL Server adds to the query. You can't add it. If you copy and paste this query, you will get an error. This is internally. I don't know why it's exposed like this, because everything that is in this text is also in the execution plan itself. So I actually never look at that text. I look at the top left operator. And the first thing I see is that I click wrong. The first thing I see is there is a new property called dispatcher. Now if I expand that, and I can't expand when I'm zoomed in, so let's first expand and then zoom back in. When I expand that, you will see that there's a parameter sensitive predicate, and that gives us a lot of information. It has a predicate that says @p equals PSPO demo.dbo.b, the column name. So this is the predicate that SQL Server identified as sensitive to skew. And this is a predicate that will need to be tested whenever this dispatcher plan is used. So whenever I execute a query, this dispatcher plan is found in the procedure cache, and SQL Server says, oh, I need to look at b equals b, and I need to look at this statistics, and now I need to look at the runtime value of b. Now this was the first execution, so the runtime value is a. For that runtime value of column b, the value a, we find an estimated number of rows of 1. That estimated number of rows is below the low boundary of 100, which means that we are now running this query for a parameter value with a low frequency. Low is coded as 1 in the query variant. So if I scroll a bit further and zoom in again, you will see that SQL Server has identified this is query variant 1. The query variant for a low number of columns that qualify. There is no execution plan for query variant ID 1 yet. So now SQL Server creates an execution plan for this query variant, and you will see that it uses the sniffed estimate of 1 row and creates an execution plan that's optimal for this. This execution plan now is stored in the procedure cache. And that's not a problem, because it will only ever be used for values that have an estimate between 1 and 99, and then this is always a good execution plan. For the second execution, with the value d, we find a different execution plan. Without recompiling or anything, we find a new, different execution plan. The reason is that now we have the same dispatcher plan. That dispatcher plan was stored in the cache and is reused. That doesn't change. But now, at execution time, we sniff the parameter. It's d, that's the runtime value. And now we look in the histogram to see the estimated number of rows. That's 100,000. That is equal to or above the high boundary. So now we get into the high range and we see that the query variant ID is now 3. There is no execution plan for this yet, so it's compiled, stored in the cache, executed, and now we don't use a seek plus lookup, we use a scan, because with 100,000 hits that is going to be faster. The third execution uses the value b. Once more, the dispatcher plan says check how many values, how many rows have column b equal to b. The statistics object, the histogram, says that is going to be 100, and that means that we are between, remember the low bound and the high bound, 100 and 100,000. We are at or above the low bound, so this is the medium range, and indeed when I scroll down you will see that I had the wrong, I was looking at this one. I forgot to scroll to the next execution plan. So here you will see that now we get query variant 2 for the medium range, and this execution plan is now compiled, optimized for the sniffed value of at b equals b, and then compiled with this sniffed estimated cardinality of 100 rows. So far it all runs fine, and yes, we had 3 compilations, but those 3 plans are now stored in cache. We now have the 3 plans for each of the 3 query variants. Nothing will compile anymore until something invalidates the cache entries. That doesn't happen here. So on the 4th execution, SQL Server finds the dispatcher plan, looks at b equals at b, and it says, okay, that is query variant ID 2 again. Do we have a stored execution plan for query variant 2? Yes. So we're reusing the execution plan that was based on an estimate of 100 and running it for 99,999 rows. You already see that PSPO is not perfect. I'm sure that in the low range below 100 we will not have issues. I'm also sure that in the high range, 100,000 and up, we will not have issues. But in the medium range, if you just look at the statistics IO output, you see that the first 3 executions were all pretty fast, but the 4th execution was not. This had over 200,000 logical reads. I would have wanted the same execution plan I had for the 100,000 Ds, which did a scan with 522 logical reads. That would have been way faster. So it's not perfect, but it's a start. Now in this example, I had just one skewed predicate. Like I said, SQL Server supports up to 3 of them. So let's change the example and use, in this case, two equality predicates on skewed columns. If I run this query, and I'm just using one execution because I only want to show how this looks in the execution plan. Now we also get, this is a completely new query, so we get a new dispatcher plan. But this dispatcher plan now has a dispatcher that has 2 parameter sensitive predicates. And we can expand each of them individually. And then you will see that one is for column B and the other is for column C. Both with those... Sometimes I click wrong. I apologize for that. Both with those same boundaries of 100 and 100,000. Now in this case, how this works is the first parameter sensitive predicate does the same as a single one. Depending on the boundaries values, low, medium or high, results in query variant 1, 2 or 3. The second parameter sensitive predicate then also looks at the different column, low, medium or high, and then adds 0, 3 or 6. And if there is a third one, then 0, 9 or 18 will be added, so that every possible query variant has a value between 1 and 3 for a single parameter sensitive predicate, between 1 and 9 if there are 2, and between 1 and 27 if there are 3 parameter sensitive predicates. For this specific execution with D and A, we got query variant 7. C was high, so that contributes 6. A is low, that contributes 1. 1 plus 6 is 7. Now that we've seen how this works, let's look a bit deeper into the qualification criteria. Because like I said, not all queries will qualify. So for SQL Server, if PSPO is active, what will happen when a query runs is SQL Server, step back, what will happen if a query runs and there is no plan associated with it? SQL Server has to compile it. At that point, because PSPO is active, SQL Server first has to make a decision. Do I create a single regular execution plan, or do I create a single dispatcher plan that then indirectly can link to multiple execution plans? In other words, do I need PSPO for this query? The first criterion is there must be a predicate in the form of column equals at parameter or at parameter equals column. Now there are some slight complexities you can add. I have seen PSPO kick in when I did, for instance, column equals is null at parameter something. But it's very limited. Basically, you have to have a simple comparison between the predicate and the parameter for PSPO to kick in. As soon as it becomes more complex, it's very likely not to kick in. Now, if a column is not skewed, then this whole setup with a dispatcher plan and other plans would be wasted. Because if the data is fairly evenly distributed, you would always get the same execution plan. You would never get low or high, or only low, or only high, or only medium. And even if you would get the same execution plan anyway, so it would be wasted overhead. SQL Server only wants to create a dispatcher plan if it makes sense. So what it now does is check whether the column is sufficiently skewed. It computes what it's called the skewness, and that value has to be at least 100,000. So how is that value computed? Well, we look at the statistics histogram. You see an example here. In the statistics histogram, SQL Server will find the highest cardinality and the lowest cardinality. And you see that this is in the EQ rows column. Frankly, based on the documentation I have found, it's unclear to me whether or not the average range rows column is checked as well. But based on how SQL Server creates histograms, it always tries to put outliers in the equality rows, and the average range rows should normally not contain outlier values, so the lowest and highest value are very likely to be found in the equality rows. If they are in the average range rows, I don't know whether SQL Server would find them or not. In the example on the screen, you will see that the lowest equality rows is 1 for Abbas, and the highest is 123 for Alexander. That is a ratio of 123 divided by 1 equals 123, far below 100,000. Now this is just a subset of the data, it's just a screenshot, there are more rows in the output, there may be higher values. One of them has to be at least 100,000 to reach that ratio. And if we had 2 persons with last name Abbas, and that remains the lowest equality rows, then there has to be a name with at least 200,000. There has to be really high significant skew. If not, then PSPO does not even kick in. And I'll show this in the demo. So let's remove the 100,000 rows, the 10,000 rows with value D from my demo table. And now make sure to update the statistics with full scan so that they are completely correct again. If I now look at the statistics, you will see that the lowest value is 1, the highest is 99,999. I see a typo in the comment here. Let's fix that. So the skewness here is 99,999 divided by 1. According to SQL Server, this is not sufficiently skewed, and if I look at the execution plan, you will see that there is no dispatcher plan created. Every value A, B and C will all use the same execution plan, which of course is absolutely not optimal for C. So this is another weak spot in my opinion of PSPO. That's minimum skewness of 100,000. That is a way too high threshold. It should have been much lower, because there are many cases with a lower skewness where you still can get severe problems. Now, if a single query has multiple predicates that all qualify for a skewness of 100,000 or more, that is when you can get multiple dispatcher expressions. Then, if there are 2 or 3, they will all run. If there are 4 or more predicates, then SQL Server will select the 3 that have the highest skewness. That makes sense. Okay. Once we know that we need a dispatcher plan, we get those dispatcher expressions. And I showed you the boundaries of 100 and 100,000 in the dispatcher expression. Those boundaries are not hard-coded. Well, not all of them. That is why they are stored in the execution plan, because a different dispatcher plan or a different dispatcher expression even might use different boundaries. So the low boundary is hard-coded. As far as I have been able to find out, and I've run a lot of tests, this is always 100. Even if your table is very large and the statistics say that the column with the lowest frequency already has 2,000 rows, the low boundary will still be 100, which means you will never get an execution plan for below the low boundary, because there are no values that, according to the statistics, can result in an estimated number of rows below 100. So I don't know why this is hard-coded, but it is. I have found pages on the internet that say something else. My demos prove or show that they are wrong, so either my demos have a shortcoming or more likely that information on the internet is not correct. The high boundary though is based off the cardinality. So once more we look at that highest cardinality that already was used to determine that the skewness is 100,000 or more. And then we round that down to the nearest power of 10, not multiple, but power. So let's once more look at a demo where I've shown this. So I created a very large table with just two distinct values, 2000 rows with the value A and 200 million rows. That's once more exactly that 100,000 ratio. That's why I had to create a very large table with the value B. And the histogram shows exactly this. There are 2000 rows with the value A. There are 200 million rows with the value B. This does qualify for, what happened here? I clicked something wrong. Okay, I'm here. This does qualify for PSPO. So let's look at the dispatcher plan that is created now. Remember, lowest is 2000, highest is 200 million. What the dispatcher now says, let's expand it, is the low boundary is still 100, even though there are no values that will ever have an estimate below 100. But the high boundary is now 100 million. 200 million rounded down to the nearest power of 10. So only values that have an estimate of 100 million or more will qualify for the high frequency plan in this case. Nothing will qualify for the low frequency plan, and everything else from 100 up to 100 million minus 1, all those estimations, all those cardinalities will all use the same medium plan, which of course means you still get a lot of problems with bad parameter sniffing in a case such as this. Far from ideal. So let's get back to the shortcomings a bit. And I already addressed some of them during the talk, but let's recapture them. First, the medium range is still highly susceptible to bad parameter sniffing. I showed that in the first demo where I had the smallest possible medium range. I didn't exactly show it, but you could see that the medium range was 100 to 100 million in the last demo. These are obviously all cases where you can still have bad problems, and you cannot just say, oh, PSPO is active now, my problems are fixed. They are not. On very large tables, the low range might not even be used. And I realize I forgot to put in the slide deck, but for tables that do not hit that 100,000 skewness, you also can have a lot of problems. So the minimum skewness criterion of 100,000, I should add that to the slide, is also way too low. And the last one, the high range, is computed of the very highest value in the histogram. And okay, we do round down to the nearest power of 10. But it's very likely in many of your tables that only that single highest value will ever use the high frequency plan. And all other values might use the medium plan. So those are, in my opinion, serious shortcomings. Also, if you have a lot of queries where PSPO does kick in, unlikely, that might happen in your system, and if a lot of them use all the 27 possible plans or close to them, then you might start to have issues with cache bloat. If you currently have a system that already suffers from cache bloat, then it might get worse, especially if PSPO happens a lot in your system. So that is a side note that you need to keep in mind. You do get more execution plans in the plan cache, which means cache bloat, which means memory pressure, which means that plans have to be evicted more often to respond to memory pressure, which results in more compilations. So that is the trade-off. If you currently do not have cache bloat and you don't have PSPO on thousands of queries with 9 or 27 plans in all cases, then this will not be an issue. But some specific high usage scenarios might have problems with this. Now let's not be only negative. PSPO also does have benefits. It is a transparent improvement on upgrade. For queries that do qualify, not enough, but some there are. For values that have an estimate below 100, you will now for free no longer have problems. For values above 100,000 or whatever the high boundary is, you will get an execution plan that's always optimal for such a high number. So for the very low and the very high range, this is an improvement. It will alleviate some of your problems, somewhat. Like I said, it fixes the worst cases. It doesn't fix everything in between, but at least it's something. So, would I turn this on? Well, it's on by default. Unless I fear for plan cache bloat, I would generally keep this on. But I would not expect that this feature will save my world. I would expect that I still have to use all the tricks from my last video to fix all the issues that there still will be with inequality, with optional parameters, and the many cases where equality on a skewed column still is not fixed because the skewness is not high enough or because the issues appear in the medium range. All those tools in my pocket are still relevant, but at least some cases are solved for free without me having to do anything unless my plan cache bloats. But that is an exceptional case that most people will not run into. So that's PSPO for you. A new feature introduced by Microsoft, not really delivering on its promise, but it does something, and who knows, perhaps in future versions of SQL Server things will improve. They haven't in SQL Server 2025 because Microsoft was busy creating another new feature, but that's for the next video. I thank you for your attention. If you like this video, leave a like, leave a comment, subscribe so that you get a notification of my future videos. I hope you like this video. I hope you learned something from it. My name is Hugo Cornelis. Thanks for your attention. Goodbye.